to look all right with the screen, and then I continue. This is seen a little bit from the perspective of northern Germany, where we still so far have regular rainfall, and where there is, of course, some good traditions for grass clover growth. If you see the slides, the date on top is not right. I did not change it because we once thought it should be 1 week before this. And 3 weeks ago, I presented a little bit more about grass clover lays for grazing. Now the focus is on cutting, and this is part of the Resilience for Dairy project, where we work together and collaborate with 16 regions, and everybody gets the chance to tell a little bit in this webinars on innovations, and I choose the legume-based forage production for this. Just to see how it looks like if I don't have a beard, but where I'm located in the very north of Germany, Schleswig-Holstein, very, very close to the Baltic Sea, and results I want to present today. They are from the research farm Lindhof, which was also part of the webinar 3 weeks ago, which is an organic farm. But this webinar here is a little bit meant also to colleagues from conventional farming that might be interested in grass clover as an alternative. And for that reason, we also made experiments on our conventional farm, Hohenschulen, where we then could compare for example, yields and quality with conventional crops. I'm from the University of Kiel, and then I will start giving a little bit of background and introduction why it is interesting to work and look at legumes as an alternative in forage production. It will discuss a bit possibilities of integrating legumes into forage production, but mainly I will have a focus today on grass clover lays in arable forage production. I would like to present the main species we commonly use here in Germany. I will talk a little bit about yield performance and forage quality, and some hints on production technology, like the management, a little bit on fertilization and conservation. But of course, in just in half an hour, not all details can be asked, but can be addressed. But please feel free to ask, and then we could discuss. First, I thought I also would have a little bit of focus on white clover-based permanent grassland, but then I found out that this will be way too much for one webinar, and the project is still running, so maybe I get the chance next time again to talk about this. Why talking about legume-based forage production? We have current challenges in agriculture production, which still has high purchase prices for energy and fuels, high prices for synthetic fertilizers, which use a lot of energy. Of course, they are fallen, but they are still high, and the future perspective is that they will not get as cheap as they have been. And we have high concentrate prices, as we mainly buy in protein, and we now look with the eyes of a ruminant. we could use legumes as an alternative and forage legumes as an alternative. There are also some climatic changes that might lead to more extreme weather conditions. I guess all of you have expected longer drought periods, that they are more likely, and that we have to learn to cope with them in forage production. And some forage legumes like red clover and alfalfa, they are deep-rooted and they might be part of a solution. There's a lot of debate in Germany with respect to a decrease of biodiversity. Grass clover is a very diverse crop. It's flowering and it's good food for flower visiting insects. We just recently published a paper on this. But unfortunately, when we talk about now again decreasing prices for synthetic fertilizers, unfortunately, it's at the moment, at least here in Germany, in combination with also decreasing milk prices again. We have, of course, some current challenges in agriculture, politics and productions. There's pressure from agriculture policy. We say that legumes are a part of the solution for climate protection. Germany has to be neutral in 2045 with respect to the climate, and that sets us a bit under pressure. And then there is, of course, the farm to fork strategy. Most of you are focused on or faced with that we want to make the European food systems more sustainable with sustainable development goals, where we say, of course, food security should be there, but produced sustainable. So we have to reduce chemical synthetic pesticides by 50%. And this may be a strong point also for the grass clover. Reduction of nutrient losses by at least 50%. Legumes have a self-regulating systems. They only fix nitrogen when they need it. And of course, we have to reduce the fertilizer use by at least 20% while maintaining soil fertility. Grass clover is very good for soil fertility, and it is self-sufficient with nitrogen. And there will be, or there is the aim of an increase of organic farming to a share of 25% in the EU, but in Germany, 30%. And animal production or dairy production, there will then have to be based more or less on grass clover. And with the increased demands for public services in the common agriculture policy, there will be demands on more biodiversity. And while German farmers, conventional farmers, still hope that they still can grow maize after maize after maize without break, this will not longer be possible in the future, but we will need the forage. And then there's also maybe the entrance for grass clover on arable fields. So grass clover could be an alternative for arable forage production. We have the grass clover lace. That's what I wanted to talk about most. But of course, there are other possibilities to have legume-based production. Of course, we can make our homegrown concentrates by growing grain legumes also on arable land, or even harvest them as whole crop silage. Then we have a kind of forage, but that is not the topic today. And of course, I mentioned it earlier, the white clover-based permanent grassland. And last but not least, but not addressed here, in future, we may also focus more again on cover or catch crops, which we really call crops because we can harvest forage from them that are not in concurrence to, for example, or not competing with cereal production. So the advantages of grass clover and alfalfa production, I just have them listed here again. They are the main nitrogen source in organic farming. They are rich in crude protein, and at least for ruminants, a real alternative to soy imports. We have higher crude protein yields compared to grain legumes. I will show some results later. From the perspective that we also have to purchase minerals like calcium and magnesium, our forage legumes, they have high contents of calcium and magnesium. I will show this later. That makes us maybe save also some money there, but give us some difficulties in dry cow management. And one important thing, what our German forage elevation system is not very taking account for is forage legumes. Cows like to eat them. They prefer them in grazing. They select them first. When they can select from silage bales, they will select the legumes. Legumes have a high passage rate, and when it tastes good, we also have a high dry matter intake. I know from Denmark that they even address some higher economical value to forages when there is legumes in it because of the higher dry matter intake. And some of you with high yielding cows know that the ideal fat component might be very good hay from alfalfa, but under northern German conditions, where it always then rains when you want to conserve it, production of alfalfa hay is very difficult and sometimes works in combination that you make harvest bales at silage dry matter contents and then dry them ready on surplus heat from biogas power plants. So and then our grass clover fields, we can make use of the fields for several years of the same sowing. Compared to maize, we need less tillage, and the alfalfa and red clover, they compete that strong with weeds that our swards just don't need a lot of maintenance. They are self-sufficient with nitrogen, and that also has a climate relevant perspective because 200 kilograms of N easily consume 400 liters of fuel to produce it. So this is, of course, relevant, and our legumes, they have a high crop rotation value because of large amounts of crop residues and the mitigation of weeds. And as I said, and I will show it, that the legume species like red clover and alfalfa, but also seen from the northern perspective, I've seen some Finnish listeners, they might know more about, for example, Elsikke clover. They are deep rooting and therefore very tolerant for drought. And grass clover has the clearest, largest humus formation or CO2 sequestration in soil. And that's very important when looking also from a climatic perspective. So this is then the end of my promotion of grass clover. Now some facts should be factors that may influence yield, forage quality, and the amount of nitrogen fixation, nitrogen derived from air of grass clover swards under our given site conditions. This is, of course, on the one hand, the sward composition, which often is determined by the seed mixture used. So we have to compare and can vary the legume species. I will show some results there. One even can vary uh, um, legume varieties. They are large-leaved white clovers, for example, better used for cutting than small-leaved ones. They are quite grazing tolerant alfalfa and red clover species varieties, but I won't talk about this here. And of course, we have the companion grass and how this competes with the grass, with the clover to take into account. The defoliation system and intensity will clear have an effect on yields and quality, and it's the same with the grass swards. The younger they are cut, the higher the forage quality, but not all legumes like alfalfa and red clover can tolerate more than 4 or 5 cuts, but I will show it in pictures. And grazing will lead to other swards from the same seed mixture as cutting, since cutting always is removing nitrogen, and that will always give strong points to the N fixing legume. Sward age will play a role, the way how you establish the swards, if it is sown directly after cereal harvest, or if it is even earlier established as an understory by spreading seeds into a growing grass clover and into a growing cereal sward, which is the way we usually as organic farmers can establish the grass clover already as understory in growing cereals, and fertilization will play a role. Give me a minute just to give a brief characterization of the most important clover species used here in northern Germany. It is mainly when we talk about forage production on leys, it will be the red clover, Trifolium pratensis, which will have the highest productivity under northern Germany conditions, where we don't have the hardest winters and where we usually have evenly spread rainfalls of around 700 to 800 millimeters per year, and where usually June, July, and August are the months that have slightly higher precipitation than the other months, but of course also a higher evapotranspiration. So, but then there's one thing: the duration of red clover is limited here, usually to a maximum of 2 production years, sometimes of 3 years. But then it is getting risky because red clover plants die off, And then it would be good to have also white clover as an additional species in the seed mixture, because that is more permanent, but I will talk about this in a minute. Red clover is drought tolerant because of deep rooting. And a very interesting thing I will show is that it has a high share of rumen stable protein. That's very interesting with this species, and this is much higher than compared to alfalfa or white clover. We use it, the red clover, for cutting, for conservation, and it's not resistant for grazing. 3 weeks ago, of course, I told a little bit about the experience of grazing red clover. They are good, but again, in mixture then also with white clover, that when the red clover is leaving the system, white clover takes over. The soil requirements, they are moderate. It needs 600 millimeters of precipitation. It's not suitable for peat or light sandy or wet clayey soils. So, and it's mainly grown in mixture with grasses. That makes it much, much easier for conservation. I will come to it. Not that common in northern Germany, but more common on the better soils of southern Germany. We have alfalfa, which has even higher protein contents than the red clover. It has more minerals, and as I said, it's very ideal component when fed as hay to high-yielding cows. But the soil requirements are much higher than red clover, and usually more deep loamy sandy loam or loam soils. We can grow alfalfa here, no problem, but it's not that easy as red clover, and usually it's cut for conservation here, and it's not resistant for grazing. And here we grow it mainly in mixture with grasses, but often it's also grown in pure stands. In our region, we need to give the nitrogen fixing rhizobium bacteria to the seeds, because they are not stable in the soil. Of course, when you have a high share of alfalfa in the crop rotation, this might not be necessary, while we here in our region don't have to give the rhizobia bacteria when we want to grow white clover or red clover. And last but not least, the nearly most common species would be the white clover. It's interesting because of the very good forage quality. We have at the same time very high crude protein contents and very high energy concentrations. And this is due to that the white clover has no harvestable stem. We have the stem laying as a kind of stolon flat on the ground, and we just harvest leaves or flowers. There's not much crude fiber in it, and a lot of energy and a lot or high protein concentration, but only with moderate protein stability. It's extremely tolerant for grazing, but it's shallow rooted. It might suffer from drought, but when drought is over, it recovers fast. It's mainly used in grazing or in longer lasting lays. And of course, here in Germany, it's the main legume species in permanent grasslands. It has comparatively low requirements with respect to soil. Of course, it's not well adapted to very light sandy soils because of drought and to very heavy clay soils. And the soil pH value needs not to be too high, and we grow it, of course, in mixture with grasses. So now I would like to show you some results where we compared alfalfa, red clover, and white clover. In the experiment, it's a 3 years experiment where I show you some average values. We did grow the swards in pure legume swards, 100% legumes, and as a mixture with perennial ryegrass, where we then reduced the seed rate of the legumes to the half and added 20 kilograms of perennial ryegrass. And for comparison, I had some fertilized perennial ryegrass swards that didn't contain any legumes, and that was done under northern German conditions with even precipitation on a loamy sandy soils in a four-cut system. Here I will show you dry matter yields first of the compared swards. In red, we have the red clover, in bluish, the alfalfa, and in green, the white clover swards. And now we are looking at the dry matter yields. Unfortunately, I used the more in German common unit in deciton per hectare. So it's a tenth of a ton. So 100 decitons would be 10 tons of dry matter harvested, just to compare it. And typically, we would have grown these swards in mixture with perennial ryegrass. That's what we did. Just for comparison, as I said, we also had these legumes in pure stands, and you can see 20% higher yields, dry matter yields, when grown with perennial ryegrass or with grasses. There are a lot of reasons for this. Limiting growth factors through also different rooting systems might be utilized better. There's a lower risk, of course, when grown in mixtures. So when it comes to the harvestable dry matter, the mixtures are yielding higher. And when looking at the pure stands or in general, the swards with the white clover harvested less because the stem is laying and is not getting harvested like with the red clover or the alfalfa. These swards had around a little bit more than 60% of legume content, which is very high, but we didn't fertilize any nitrogen to these swards. And now I want to compare these yields to the potential a typical grass crop would have. And I compared the dry matter yields to perennial ryegrass. And that's why we needed a conventional experimental site. The legume swards were more or less managed organically, but compared to conventional managed perennial ryegrass, where addressed variation of 0 to 400 kilograms of nitrogen to it. And as one expects, with increased nitrogen yields, nitrogen fertilizations, we have higher dry matter yields there. but at one point of time with 300 kilograms plus, the maximum is reached. But for us, interesting was to see how much nitrogen I could save when growing grass clover in comparison. And with the red clover grass, in an average of 3 years, we could harvest as much dry matter as a sward that was offered 250, 260 kilograms of N was harvesting. So one easily could say, okay, 260 kilograms of N saved, and that's interesting. On the other hand, one could ask, why do these legume grass swards not yield higher? In very dry years, they do it, but I don't have have the time to show you some results there. But in the typical years, they don't. But one reason is simply that self-sufficiency of nitrogen needs energy, and 20% of the photosynthesis energy used of the legumes is used for fixing the nitrogen. So it's clear 20% of the yield potentially is invested in self-sufficiency, while fertilized swards, of course, need a lot of energy consuming mineral nitrogen here. Comparison now to the crude protein content, and that's then one of the strong points, that none of the high fertilized perennial ryegrass swards could reach that high crude protein contents than the grass clover in a four-cut system here. And then we can see the strong point of pure swards of, for example, alfalfa or red clover. They have very, very high crude protein contents and might be very ideal in combination feeding with silage maize. And of course, if there's a grass component in the mixtures, then the crude protein content is reduced, but still higher than of the high fertilized grasses. We're looking now at the energy concentration. And then here I have to say that for some of you, the German version of how to evaluate energy concentration might be not familiar. We use a unit called net energy used for lactation. And we say that a kilogram of milk uses around 3.2 megajoules NEL. When we have here energy concentrations of around 7, then we are way above 11 and a half megajoules of metabolizable energy, just to translate it. And here there is this point, a strong point, that swards with red clover, they have a little bit less energy concentrations than pure grass swards. And since white clover is easier to digest than even perennial ryegrass, swards with white clover even have higher energy concentrations than perennial ryegrass swards, which I found interesting. Interesting also that perennial ryegrass, when it has a lack of nitrogen, like in the red and blue column, has higher energy concentrations. But this is because of very, very high sugar contents. When you fertilize very high, a lot of the sugar is used to bind the nitrogen in high fertilized systems. And when it comes to the energy yields, here I have it in gigajoules of net energy lactations, but maybe it's only interesting to see how much I should have fertilized to reach the same yields with the grass clover swards. Then we had to offer 200 kilograms of N to a perennial ryegrass sward to have the same energy yield. And here we again have to take into account that 20% higher yields theoretically could have been possible, but they are used to make these swards self-sufficient with nitrogen. So I guess that we will need at least in humid climates 20% of more area to grow the same amount of forage. Under dry conditions, this might be slightly different since red clover and alfalfa are deep-rooted. And then an interesting thing, how much nitrogen do we harvest and how much nitrogen do we harvest from the perennial ryegrass when having fertilized even 400 kilograms, we won't harvest more than 350 kilograms of N. But this already leads to the strong point of grass clover production. We reach huge amounts of nitrogen without having offered nitrogen. And you even can't fertilize grass sward to reach the same amounts of nitrogen. But of course, we don't want to harvest nitrogen. We want to harvest protein. And here I did not convert it to crude protein yields, but you just have to multiply it by 6.25, and then you have protein yields. I did the same here and said, when I harvest 300 kilograms of nitrogen, this corresponds to a protein yield, a crude protein yield of nearly 1,900 kilograms, and 350 kilograms would be approximately 2,200 kilograms of protein. And then I compared it, if we could grow 2 tons of field peas with 20% of crude protein, we only could harvest 1,100 kilograms of protein. And here my point is forage legumes can yield more protein than the often promoted cereal legumes. And this is a strong point. There is one more tiny thing, which is then the N amounts in the leftovers, the crop residuals of grass clover. Of course, we have a lot of crop residuals when once plowing perennial ryegrass, much more than in other crops, but our grass clover fields, they leave around 100 to 120 kilograms of N in their crop residuals, which is good for the following crop. And if we take all the N amounts in the crop residuals, which are higher compared to the perennial ryegrass and higher, there are also the protein or nitrogen yields. We can look at the nitrogen fixation of these grass clover lays, and here in our swards, we could calculate that they have fixed around 300 kilograms of N from air and put into the system nitrogen that we don't have to buy in from somewhere else. Parts of it, they are in the yield, parts of it, They helped, of course, to put nitrogen into the crop residuals, but this is part of the yields. And then some more small things, and then I have a little bit had a problem that I forgot my final version at home. I have now some not that professional translated slides, but I hope that you could follow my points. Here I have different legume species. The main ones I marked with the colors: alfalfa, white clover, and red clover. And I have the perennial ryegrass here, and compared the calcium contents per kilograms of dry matter. You can see easily double amounts of calcium, which on the one hand saves some minerals under feeding, but on the other hand, it makes ensiling a little bit more complicated, because these two loaded ions, they buffer ensiling. So not everything that is good has also some bad sides. That's what we have to take into account. And of course, the high crude protein content may have an impact also on buffering the pH in ensiling legumes. And but what's then with the quality of protein? And so far we just have talked about crude protein, but we are maybe more interested in rumen stable protein, the undegradable protein. And there I found a study of Broderick and Albrecht. Unfortunately, I once translated it to German, protein quality, but here we have alfalfa, white clover, and red clover. And we have the undegradable or rumen stable protein. And we found that the red clover has very high shares of it. And this stable protein we want. And while the alfalfa and white clover has just typical values for green forage. And when we compare this to other forage components, this is much higher than what we would find in grass. Grass, of course, I would have written with 2S if I would have translated it a little bit better. But we come very close to soya extraction meal. So the red clover seems to be very interesting. And this is because of a secondarily metabolite, polyphenol oxidases, that stabilizes the protein. So red clover has a strong point here, but not only good things, and then I also, of course, have to come to a kind of an end. With conservation, it's a little bit difficult with legumes. Legumes have less water-soluble carbohydrates than, for example, ryegrass, and of course, compared to silage maize. This what we also have to take into account when ensiling it. That's why also high shares of grass might be interesting to improve ensiling. I'm not sure if I should have explained the next slides, but this is from some slides where we ensiled mixtures. Oh, there's somebody with a microphone 10.
Ich kann dir löslichen anbieten.
Okay. Discussing coffee. Silage mixture, when we have it with 100% of legumes, and that's alfalfa and red clover in mixture, or compared to 100% of perennial ryegrass, or mixtures with a share of 67% of legumes or a share of 33% of legumes, we can see a lot of things that, for example, the dry matter content is much higher the share of grass. But this also has to do with the stem of the legumes that wilt and hold the water too long. Of course, the crude protein content is highest when also the legume content is highest, but the energy content, and even if it was getting bad silages, is of course higher when the share of grasses are higher. And here we had the losses during ensiling, and they were much lower the higher the grass content was. This what we have to take into account. Before I sum up, we use not a common technique when harvesting, not just mowing. We always use a conditioner, and that helped us very, very much with good silage quality. But of course, then we need to wait on very, very stable weather conditions, but which one also already can, since legumes, they don't lose the forage quality that fast. And when it comes to some management factors, we always have to take into account that clovers, the nitrogen fixation of the clovers needs protons. And that means that compared to ryegrass, the pH value of the soil decreases with red clover compared to ryegrass. That needs, we have to have the liming, the calcium and pH regulation in top when growing clovers. And we have to take into account that sulfur may be a very important thing when fertilizing it. There are a lot of experiments, and you easily can see a difference in color. It would look like if we don't fertilize sulfur, but of course we can fertilize sulfur with slurry, and you get much higher yields when you have sulfur available. And one last slide before I sum up. What's with the fertilization with nitrogen? Of course, I took it from some extremes. We in this experiment made a mixture where we had a quarter of the seed rate of alfalfa, white clover, sorry for not translating it, and a mixture of perennial ryegrass and cocksfoot Dactylis glomerata. And what we did with the same seed mixture, all three swards you're looking at, they had been the same seed mixture. And then after 1 year where we applied a 3-cut system, these swards developed like this. And we consequently used a 5-cut system. The same seed mixture developed like this. And when adding no nitrogen, we nearly had a pure alfalfa sward. When adding, of course, a lot of nitrogen, alfalfa disappeared. When adding a lot of nitrogen to a 5-cut system, it was a pure perennial ryegrass sward. And when adding no nitrogen to this system, we got a grass white clover. But as a last thing, we compared the greenhouse gas emissions of these two swards in the following slides. And when we looked at, and sorry, I have to translate it, but the next and last slide will then be in English again. When it comes to the energy yields, there nearly was no difference between the grass or the grass clover. When it came to CO2 emissions, taking into account also the energy consumption that was burned off when producing the 360 kilograms of N, we saved half of the CO2 emissions by growing grass clover. When you apply mineral fertilizer N on wet soil, you have increased N2O emissions. This is the orange part. We don't really found N2O emissions. And when it comes to specific CO2 equivalents per unit of harvested energy, the CO2 emissions of grass clover were much lower. We also have published this in English, but I apologize that I had the wrong version with me today, but hopefully these 5 that you can apologize for the last 5 very quick translated slides, but you can ask. But my conclusions are Lays based on forage legumes are an alternative in production for crude protein-rich and mineral-rich forage. Seed mixtures containing red clover or alfalfa can achieve very high protein yields without additional N fertilization, and they nearly can't be realized by the heavily fertilized grass swards. And I said 20% of the potential yield of grass clover swards goes into self-sufficiency. So that might need that at least under our moderate or humid climates, we will need 24.5% of more energy. And a great attention has to be paid to fodder conservation, as I said, but because of the high root performance, high humus performance, high CO2 binding in soil, and low CO2 and nitrous oxide emissions, legumes are a mitigation strategy for the climate gas debate. And that's where I want to finish. And thank you for your attention. And of course, you also could graze grass clover fields. So a lot of talk. Mm-hmm.
Thank you, Ralf, for this interesting presentation. So if anyone has any question, please write it in chat or just raise the hand as André Legal did it, so you can ask your question. Your microphone is...
Thank you, Ralf, for this nice presentation. So, very interesting about legumes. I have a question about carbon sequestration that you mentioned in the previous slide. Have you some results about the difference between carbon sequestration with SWOT with PRG, for example? onto the road with legumes in terms of carbon sequestration, according to the depth of the roots?
It's very difficult because it really needs a lot of long-term experiments. It takes years, and of course, on the one hand, it will be the high amount of crop residuals which take a part of it, but it also needs well-balanced crop residuals. That you also need nitrogen-rich crop residuals for good humus production. There's a bit of a strong point for the legume based swards, but on the other hand, we also have to take into account the deep rooting that alfalfa and red clover will penetrate also the soil very deep and have significant deeping roots, which then are getting more carbon into the deeper layers. So there is a strong point definitely there. Unfortunately, our experiment was too short to detect these systems. Slightly, there had been more carbon sequestrated when alfalfa was compared to the grass.
Thanks.
Mm-hmm.
There is another question in the chat. Is the S in slurry active? What's the percentage that is absorbable for the grass clover? Can you see it, Ralf?
No, I can't. Okay, sorry,
In the chat.
I did not the chat. I would say so far I have just presented here slides from our experiments without the slurry, and sometimes especially in our on our farm Lindhof, we before we started with a lot of grazing of these swards, we never used slurry for the grass clover, since we said, okay, that might nitrogen fixation do, and we might reduce nitrogen fixation, but we really could see this deficiency. We haven't started with slurry on grass clover fields, but we have started grazing of the grass clover fields, and there the slurry was more or less replaced by dung and urine, and we never saw sulfur deficiencies there. You can see when you apply the slurry, and we never found sulfurous deficiency in with the first cut, because then still winter mineralization, and the mineralization gave us sulfur, but it was the second cut. There we could help with the slurry, but I definitely would make an experiment and leave 12 meters out just to see what happens. But I guess when you are a specialized forage producer with a dairy herd, then sulfurous would not be a problem, but one has to make the balances, and also has to take into account that now we stepped out of burning of coal, sulfur for free is not longer available, but that was already for 20 years ago.
I hope that answered your question. Any other questions? So far, no other questions. Then I would thank you, Ralf, for the interesting webinar and have all a nice day.
Okay.
André Legal?
Yes.
Yeah, maybe the last question on have you some slides about your trial at Lindhof with a grazing system with mixture with association with clover? Are you some results about that?
The webinar 3 weeks ago contained a lot of these slides, and we potentially were thinking of making an additional webinar, since we also at Lindhof have herbal forage plants like the plantain and the chicory in our grazing swards there. And this would be typical a presentation where we then can compare the white clover grass with the white and red clover grass mixture, and then a mixture where we in addition added chicory and plantain. And yeah, there are a lot of interesting things. So we start in reality grazing when the swards still are dominated with the red clover, and when the red clover after year 1 steps out, the white clover takes over. And yeah, I could give an additional webinar, and I guess that Valerie would be happy.
Okay, it's okay. I am going. I am just looking for with your last the slides of the last seminar. Thank you very much.
Thank you. Thank you. Okay, then if there are no additional questions, I apologize again for the last 6 slides. Gave you some impressions about German words, but I tried to translate, and at least with some typing files mistakes, had some headlines in English. Okay, then.
Okay.
Thank you. Okay, then.
Yes, thank you very much.
Thank you.
Thank you.
We will close the session. It will be available on our website of the project. And yeah, if there are any questions, you can always contact us. We will answer. So have a nice day, everyone, and see you soon.
See you. Okay. Bye. There's
Bye.
maybe a last comment, but okay. Thank you. Okay, Caroline, and see you.
Wir sehen uns.
Okay. Ja, gut.
Tschüss.
Tschüss.